This talk is about Gradle, something that people I think love to hate. People love to hate their build tools, I think in general. I think the only people who really like are passionate about loving their tools are like the C guys who love their make files, I think. I don't know if that's true or not, but it feels like it is. In any case, this is going to be a fairly quick talk on just some tips and tricks that I've come up with over the years and that I think are fairly easy things that you can do in your Gradle builds that will make them a little bit more maintainable. I was talking to somebody actually just the other day. I was going to say more readable, but then he convinced me that saying things are more readable is actually not a great way to describe things, because it's only readable if you know how to read it. And so I wouldn't say more readable, but simpler is one of the goals we're going to shoot for. So that's what we're looking for here. So powering up your Gradle. I'm going to try and move this off the screen here. Okay. All right. So everyone can see it okay? Yeah. All right. All right. So let's see. So first off, we're going to have a quick Smackdown. Thought it was appropriate. There's people often talk about, Maven's better than Gradle, Gradle is better than Maven. Well, I went out to find bad examples of both. And, here's what I found. Let's see. So here's this guy. This is a Maven POM file. It's kind of crazy. I don't even know how many lines it is, but it's pretty incomprehensible, I think. It took me about a minute to find this, just Googling around. All right. So, and then in the blue corner, we have the Gradle build file. I'll leave it to maybe Amitai can give the Randy Savage impression. I'm not sure. Let's see. So here's the Gradle build.
I'm not familiar with that kind of cultural reference. I know he's a wrestler.
Yeah. Oh, yeah. There you go. That's it. All right. So here's a Gradle build file. This is, kind of crazy. A lot going on in here. But, it was interesting because I spent about a good 10 minutes or so looking for a really bad example. And this is the worst I could come up with. And I was hoping I would find something a lot worse. So I was kind of surprised when I didn't. Like, this is, I think it's still kind of incomprehensible, but it's a lot smaller. Significantly smaller. So I don't really know what that means. It was not a scientific study by any sort of stretch of the imagination. My goal for the Smackdown was to prove that no matter what build tool or framework or anything that you're using, you can be equally bad in any of them. I'm not sure I succeeded in that. I think it's easier to make really bad stuff in Maven. So I don't know, maybe not, but that's what my non-scientific study showed. All right, so there's that for you. All right, I'm going to go through 4 little sections here: getting consistent, getting repeatable, getting current, and getting fast. All right, so getting consistent. All right, so this is something that I see a lot in people's Gradle build files. Is they have these different styles of doing things. So when you're writing a Groovy Gradle script, you can write your dependencies in any of these ways. So you can specify the group name and version separately. You can put things in parentheses. You can use single quotes. You can use double quotes. You don't have to use parentheses. And more often than not, I see build files where there's a combination of all these things in the build file. And I think primarily it's because people are copying and pasting these things from other sources. And really what happens is when you end up with any sort of reasonable list of dependencies, it just becomes harder to just look at a glance and see what's going on. So I think just, the other thing I forgot to mention is that most of my stuff is I'm trying to go from the easiest things to change to the hardest things to change. So this is one of the very easy things to change. So try, make your dependencies kind of look the same. And one way you can do this is by not using Groovy. So Gradle does have a Kotlin DSL. And if you were to write this in Kotlin, there are actually only 2 ways to write your dependencies, where you can specify with name parameters the group name and version, or you can use the just the regular, the shorter condensed version. And you have to use parentheses and you have to use double quotes. So it makes it a little bit easier to use. I'm also a big fan of Kotlin, and I also am a big fan of the Kotlin DSL for Gradle. You get it's type safe, you get better refactoring support and so on. And it's very, very similar looking to the Gradle build files. In some cases, you can just rename your build.gradle to build Gradle KTS and it will continue to work. There are a few changes you'll have to make. All of the Gradle documentation has examples in both Groovy and Kotlin, so you can easily find examples for either way of doing it. So anyway, that's one of the things I like to do is just switch things over to Kotlin. The claim is that the performance is better and things like that as well. I think when it comes to like Gradle performance, which I'm going to talk about a little bit later, but I don't actually see it as often just because I tend to try to keep my modules and applications small. And when they're small, then the differences in build times are not going to be as significant. When you do get into very large projects, though, really focusing on some of these performance things can make a big difference. And using the Kotlin DSL can help as well in that case. All right. Plugins. This is another thing that I see quite often. On the left side, we have the old style of plugin application. So you want to include a plugin, you have to do this apply plugin thing. You write this build script section, put some dependencies in there, and you get your plugin. It's been around for a long time, but you still see lots of examples of the old style. But this new style of plugin block is here. This again is something that you can, in theory, gives you better performance because the plugin resolution is better and it's got, they can cache it more efficiently and things like that. But again, I don't really see that on small projects as frequently, but this is a very easy thing that you can do. Just strip out that whole build script section. There's really not very much reason to have those build scripts any longer. In almost all cases, you can get rid of them. Yeah. All right, get repeatable. Let's see. All right, always use a wrapper. So you should be using the Gradle wrapper. And the reason we want to use a Gradle wrapper is that it ensures that anybody who's using your project is using the exact same version of your Gradle build file, of Gradle itself. So if you just run Gradle on the command line, just like with, just the word Gradle, what happens is that it will use whatever is on your path, on your system path. So if you have whatever random version of Gradle you have, you're going to end up using that to build the project, which could, in theory, lead to some problems. Some dependencies might be resolved slightly differently, depending on how far apart the Gradle version that you're using is from the one that the project is expecting. When you use the Gradle wrapper, you use the command Gradle W, and when you use that, it will automatically download that version if it doesn't already have it. If your computer doesn't already have it cached, and then it will use that version to actually build the project. So it's kind of like it bootstraps itself. Okay. So for anybody who's using Gradle wrapper already, so the way you install it is just right there. You just use Gradle wrapper and then specify the version you want. 771, I believe, is the current, or maybe it's 711. That might be a typo. All right. In any case, anybody who's using the wrapper, I would wonder, has this ever happened to you? Let me see if this works. There we go. So you go in there, you try to type your Gradle command. It says command not found. Then you're like, oh yeah, you're supposed to use /Gradle. So then you run that, but nope, still doesn't work. Oh, I'm in the source directory, it looks like. So you got to back up. You run your Gradle W clean build. Still command not found. I got to use /. Then you're like, oh, dang, I put Gradle instead of Gradle W. And then you finally run it and you say, okay, there we go, Gradle clean build, great. And so now it runs. Anybody have this ever happen to them? Happened to me all the time until I found GNG, one of the greatest names of a tool that you can ever find, GNG. So this tool is pretty cool. It's a very small little utility. Just install it with Homebrew if you're on a Mac. I'm sure there's some way to install it on Windows as well. And anywhere in your project hierarchy now, you can just run GW and clean build, and it will find the correct Gradle wrapper and it'll just run it for you. So that's kind of a nice thing to have at your fingertips. And you can kind of simulate some of this stuff through aliases and so on, but I find this this guy a little bit more helpful than even using aliases. All right. All right, get current. This is one of my pet peeves. I find a lot of teams that are using Java 8. It was released in 2014. There's a lot of new stuff since then. The current LTS long-term support version is Java 11. The latest version is 16, and the new version 17, the new LTS version, is coming out like in a few weeks. So, you know, if you're on Java 8, stop. Let's move on to something else. You know, you'll get better performance and you'll get new language features and so on, which, you know, don't directly impact Gradle, but it will be helpful for your life overall if you're programming in Java. All right. Java also has, Gradle also has this concept of Java toolchains, which just got introduced, I think, in Gradle 6. It kind of replaces the source compatibility, target compatibility thing, and it ensures that the whole tool chain you're using can actually support the language that you're specifying. It's pretty straightforward how to set it. This is the Kotlin version of how to set it, and that's it. So it's just, you know, a very small little setting that you can do. Okay. All right, Gradle itself. So, you know, get yourself on the latest Java. Get yourself on the latest Gradle. Gradle also has lots of usability performance improvements, so you can upgrade it pretty easily. I think I forgot to specify how to upgrade it, but essentially to upgrade it, you just run that same Gradle wrapper command, and you can just specify the current Gradle version, and it will give you the new Gradle version. Okay. And usually what happens, I think, when people are on very old versions of Gradle, particularly, or this goes for really any kind of software, you know, you try to upgrade from like Gradle 4 and you want to get to the latest Gradle 7 or something like that. You upgrade it, and all of a sudden, like, just everything's breaking, right? Nothing's working. You can't tell where to start and how to fix it. So usually what I would do in those cases, just go one step at a time. Just go from, you know, if you're on Gradle 4, go to Gradle, the latest revision of Gradle 4. Make sure that works. Make sure you're not getting any warnings or deprecations. If you are, fix them. Then go to Gradle 5. Then go to the latest version of Gradle 5, and so on, then 6, then 7. You find I think you'll save yourself a lot of grief by doing it that way, and commit at each stage. So you can easily roll back when you make major mistakes, like I usually do. So, all right. There's a great plugin that I love called the Gradle Versions plugin. This is really great for keeping yourself up to date. Once you install this, you can just run GW, assuming you ran that Gradle using the Gradle wrapper or the Gradle wrapper. You can run GW dependency updates, and it will give you a nice report of all of the dependencies that you have in your project, which ones are current, which ones have new releases for them. It'll also tell you if your Gradle can be upgraded. And so that's a really nice, handy tool. As a side note here, nobody ever wants to type dependency updates. So you can actually, in Gradle, as long as you come up with something that's non-ambiguous, you can just use the camel case, a shortened camel case version of this word. So I think you may even be able to use DU here, and that will work as well. So you can just do GW DU. I think there might be one other one that conflicts with that, but as long as it's not ambiguous, you can use it. Yeah, so that's a nice nice thing to have. You know, there are also tools like Dependabot and so on that you can point at your GitHub repo, and it'll tell you when you have things that can be upgraded. I don't mind those things. They're okay. They submit pull requests and so on. For some reason, I don't know, maybe it's just, I don't know what it is, some hang up that I have, but I prefer just kind of like seeing what things can be updated and just kind of going in and just manually changing them. Rather than merging these pull requests and things that get created by Dependabot. So, but some people like that, so it's a good option. This is kind of the same thing. Same with when you find that your versions of whatever are way behind, just go up incrementally rather than trying to go to the newest version right away. All right, so all right, get fast. So let's see, what else do we have in here? The build cache. So what the build cache does in Gradle is it reuses the outputs. So if you have a compilation step and that compilation, that whatever's compiled, we put into the Gradle cache. And if your next compilation, there were no changes that would have affected the result, it'll just pull the cached version of the results. So essentially the compiled code in that case. And it'll just use that, and we'll just say, well, I don't need to compile it, and I'll just continue to use it. Same for tests, same for really any of the other stages that are in your Gradle process. To enable it, all you do is you org Gradle caching equals true. You drop that in your Gradle properties, and it'll take effect. That one can save you quite a bit of time. And there's even this is another thing that's not so useful for smaller projects, but for larger projects. You can actually share Gradle caches across machines. So you could have a server on which you store a Gradle cache, and it can just basically be a distributed, or not really distributed cache, but a centralized cache that if I'm running a step in my Gradle process, it'll just go out and check to see if that's already been run by some other user. And if it has, then it'll just download that and just use those results rather than redoing it locally. I personally have not actually used that, but it does exist. Okay. All right. Parallelizing tasks. This is another easy one. This is really effective when you have multi-module projects. So if you have like a root project, and then you have like maybe like an API and a web and a blah, 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 and this and that, a couple libraries or something within the project, this can be extremely helpful, but it's even helpful on smaller projects. Just drop this org parallel equals true, and next time you do a build, you'll see that multiple things are running as once. Assuming you have multiple cores on your machine, it's helpful. If you have a single core, which I don't know that anybody does any longer, then obviously in that case it won't help you at all. It'll probably harm you, but for multi-core it works great. Yeah. Test performance. So for improving test performance, the best thing you can do is identify and fix your slow tests first. Right. So if you've got a test that takes a minute to run or something, then no amount of Gradle tweaking is going to make that thing go any faster. So identify and fix those slow tests. Make sure that your tests are independent, meaning they can run in any order. If you have tests that are dependent on each other, anytime you try to parallelize them, you'll run into weird race conditions, and it'll be very difficult for you to debug what's going on. So those are good things to do regardless of whether or not you end up parallelizing your process. But assuming you do, the thing in here that gives it the parallelization for the test run is that max parallel forks line. And this is just this is like a little snippet right out of the Gradle docs. And this is just the Kotlin syntax for using half the number of processors that you have, or at least one processor, or one fork. And so, yeah, so that's what that does. There's also a line in here that says reports the HTML required set false. So that by default, the test runner will create HTML reports. If you never look at HTML reports, why bother having them? So, you can just set that to false and just, that'll probably save you like half a second or something like that. So, every little bit counts, I think. And then assuming that you're using JUnit, then use JUnit platform is the way to go. I don't think that it does anything for performance, and it actually is really not appropriate here. It doesn't have anything to do with Parallelize, but that's just the configuration for JUnit tests. All right. I've tried to put links on here also for all the kind of sections that we'll talk about this stuff in more depth. All right, let's see. All right, this is just the last little bit that I have here. Gradle recently, I think maybe in version 6 or 5, I guess, so maybe it's been around for a while, has introduced this build scan. And what you can do is just run Gradle build and put -- scan on it. And when you do that, it will run your build and submit it to this centralized server. I think it'll actually give you a link at the end of your test, your build run. And when you go to that, it'll give you essentially a profile of your build. So it'll show you how much time was spent on every different section, how much time was spent on the configuration versus compiling versus testing versus resolving plugins, resolving dependencies, all that kind of stuff. And you can see if there's anything that sticks out, it'll be helpful. And it'll also give you some tips if you haven't done some of these things like parallelization and so on. It'll point you in the direction of doing that. So there's also a lot more Gradle performance tips down here on this link. And that's it. Those are some easy stuff you can do for your Gradle and get it back and working in a nice, simple way.